Hello and welcome to the course Climate Hazards and Disaster Mitigation. Today we are going to discuss the summary of heat waves and heat stress. So what have we learned so far? We understood the criteria to define heat waves and examine its causes and impacts. We appreciated the concept of heat stress and its relevance in amplifying heat waves, and we analyzed the drivers, causes and impacts of urban heat island. So today we'll be enlisting the criteria of heat waves, its causes, drivers and impacts. We'll discuss the importance of heat stress and methods for its quantification, and we'll explain the concept, causes and impacts of urban heat island. So to begin with, what is a heat wave? So a heat wave is a period of abnormally high temperatures which are more than the normal temperature that occurs during the summer, particularly in the northwest and south central parts of India. Heat waves typically occur between March and June, and in some rare cases it extends till July also, particularly in the northern part of the country, where if the monsoon is delayed, that is due to the prolonged heat wave conditions, the monsoon might get delayed, and in July also you can experience heat wave kind of conditions. Moreover, sometimes there is break in the monsoon. Initially there is some rain spell, and then after that there is a prolonged dry spell, so that time also heat wave can accelerate. The extreme temperature and the resulting conditions that have very adverse effect on the living of people, and heat waves can cause lot of psychological stress as well as result in death in extreme conditions. So heat waves are becoming very common, and a very large part of the country is exposed to heat waves, and in a changing climate it is predicted that more and more heat waves will occur, which will be very detrimental to the ecosystem as well human health. So understanding what criteria is there adopted to classify heat wave. So India Meteorological Department has laid down certain criteria which are based on absolute threshold. So this absolute threshold includes that if it is a plain area, so then it is 40 degrees Celsius. So usually less than 500 meter elevation should be plain area. So we can check the exact definition, but that is a tentative one. Then hilly area, greater than that can be hilly area, so that the threshold is 30 degrees Celsius. So if the T max is greater than 30 degrees Celsius in hilly area, then you can term it as a heat wave, and in coastal area the threshold is 37 degrees Celsius. Also, heat wave condition will prevail when your normal temperature, if it is deviating 4 to 5 degrees Celsius, if the normal temperature is 40 degrees Celsius and the deviation from normal is 4 to 5 degrees Celsius, then you say there is a heat wave. Or if it is below 40 degrees Celsius, your normal maximum temperature, and your deviation is 5 to 6 degrees from normal, it is called a heat wave. Now what do you mean by normal? For example, let us say 1st May. The normal temperature for 1st May is, let us say, 38 degrees Celsius in a given region, and on that particular day the deviation from normal is 5 to 6 degrees Celsius, then you call it as a heat wave. And if the deviation is 7 degrees Celsius or more, then that is a severe heat wave. So depending upon the deviation and the criteria suggested by IMD, the heat wave conditions prevail. So even if the temperature, it is a plain area, it is not crossing 40 degrees, but if this criteria is enforced, then also you can call it as a heat wave. So these two criteria have to be looked at while defining heat waves. So this is for regular heat wave, this is for the severe heat wave. And irrespective of the normal temperature, if the temperature is 45 degrees, then you call it a heat wave, and it is 47 degrees or above, that is a severe heat wave. So irrespective, the normal is whatever, but when it crosses 45 degree or 47, it is heat wave and severe heat wave respectively. Some researchers have used other criteria also, like they use 90th percentile of T max to classify heat waves, or they use 95th or 99th percentile to classify extreme or severe heat waves. So that is a percentile based classification is also adopted. Next is heat wave warning. So IMD have given color coded on that. So if it is a normal day, that is a green color where no action is required, your maximum temperatures are within the normal limit. Heat alert, that is a yellow alert which is provided. So many a times in newspapers and news you might have heard that IMD has issued a yellow alert or orange alert, so that is based on that. So yellow alert is when your heat wave conditions in a district persist for at least 2 days, then it is a yellow alert. So in that time, you know, certain activities are restricted, like outdoor activities are restricted. Then you have orange alert, where you have to be prepared that something is going to be severe, where your severe heat waves last for 2 days or regular heat waves persist for 4 or more days. So in case of orange alert, let us say your schools might be cautioned that you know, schools have to be shut down. Outdoor construction activities where workers are open to atmosphere, they have to be minimized or shut down. So that kind of situations have to be taken, or measures have to be taken. An extreme heat alert, that is red alert, where your severe heat waves is for more than 2 days and your total number of heat or severe heat days are likely to exceed 6 days, that is a red alert. So that is a very alarming situation in case of heat waves. What are drivers of heat waves? So usually if we see that your greenhouse gases, they are the primary drivers by you know, they are escalating the global earth temperature by some amount. Then the cyclonic effect, they also, you know, cause climate fluctuations. Your high pressure systems, they also result in, you know, transfer of heat from one place to another. El Nino cycle, El Nino is usually associated with the drought and heat wave conditions over Indian subcontinent. Landscape changes, these are more local. If there is a large scale deforestation or urbanization, that could also escalate heat wave. And soil moisture memory, so dryness of the soil can also result in heating. Now if we look at the scales, so on the time scales, so this on the x-axis you can see time scales, it can be multi-annual to sub-seasonal to multi-day, and in the space scale it ranges from local to regional to continental to planetary. So greenhouse gas effect is a planetary scale effect. Then you come to modes of climate variability, where you have this ENSO, IOD and other phenomena. So these are more continental scale effect. Then and some of them are planetary also, but more on continental and planetary in between. Then you have atmospheric pressure systems like planetary waves, blocking patterns, etc., which are regional. Then you have aerosol forcing, that can also affect. And then lastly, land use, land cover change and soil moisture, they are more local phenomena. So this is how they vary on the time scale. Your ENSO and all greenhouse gas effect, they are multi-annual if we see the time scale. If we see the planetary waves, they are more sub-seasonal, and even land use, land cover and aerosol forcing and heat advection, they are more of a multi-day event. So this is how the space-time variation of a heat wave can be visualized. What are the impacts? So first and foremost, the impact is on health. Those who are studying the psychological part, they will see that the human behaviors would change when they encounter heat wave. People tend to become more irritated and more discomfort, particularly those who are having pre-ailments. The risk of cardiovascular diseases is much higher. Next is many active pathogens will be active because of such environment. Then disease carrying vector-borne diseases are more prominent. Environmental degradation is also very potentially possible, and then it could impact a host of ecosystem players. Health impacts are very severe. You can have heat illness, increased morbidity, that is in case of a very severe heat wave, or there can be hospitalization as well. What's the future in store for heat waves? So the IPCC, that is Intergovernmental Panel on Climate Change, that has projected a significant rise in the heat wave risk in future as per IPCC AR6. So the frequency, intensity and duration of heat waves would increase. There is higher probability of such extreme events. The impact will be disproportionate. Some areas will be very severely affected, other areas would not be. The nights would become more warmer, and the severity depends on the emission level. So if the emission levels are consistently higher, the severity would increase linearly. What is a heat stress? Heat stress is a condition where your body cannot shed excess heat, which leads to increase in the core body temperature, as well as the heart rate also increases. So it is a combination of environmental factors as well as the metabolic heat from the physical activity and clothing. So for example, your body tends to have more metabolic heat. There is high temperatures outside, and you are working in such environment where you are required certain clothing like PPE kit or other dresses, then that can also cause increase in the heat stress. So these are all combination. What can be the impacts of that? You can have heat exhaustion and cramps, and in severe cases heat stroke, and that can lead to a medical emergency. Some indices to quantify heat stress, that is excessive heat factor, which combines short term and long term components of the heat. Then heat index, that combines temperature and relative humidity. There is another index called humidex, which combines temperature and vapor pressure. Apparent temperature, it includes temperature, vapor pressure and wind speed. And lastly, wet bulb global temperature, which is a function of dry bulb and the vapor pressure. So few of the indices we'll be discussing. The first one is excessive heat factor. So there are two components of that. First is excessive heat index, EHI sig, and second is heat stress index, that is EHI acclimatization. So EHI sig measures the daytime heat. So it is denoted as, you know, so it basically calculates the anomalies with respect to short time. So this is a 3-day average temperature, and that how it is different from the long term 95th percentile value for a given reference period. So we can consider any reference period from 1961 to 1990 or 2001 to 2024, depending upon the study. So it will give you the short term changes in the heat wave conditions. Next is heat stress index, which measures the acclimatization of how hot the recent days have been compared to the past month. So this is a 3-day average temperature, and this is the monthly average temperature. So we want to check how anomalies are behaving, and compared to the past month, how hot or cold have been the last 3 days. So if these index are positive, then we quantify them as the heat waves. If they are negative or zero, then we can say that the heat wave is absent. So excessive heat factor is a product of these two, that is EHI sig multiplied by maximum of 1 or heat accumulation. So heat wave is considered when your EHF, that is greater than 0, and the daily climatological Tmax is greater than 35 degrees for 3 consecutive days. So this is a criteria to establish the heat wave. Now what is the severity? Based on EHF, the severity is calculated as EHF divided by EHF 85, which is the 85th percentile of your EHF. So your intensity can be classified as if the severity is less than 0, there is no heat wave. Between 0 to 1 it is low intensity, between 1 to 2 moderate, and greater than 2 it is a very severe heat wave. Next index is the heat index. This heat index, you know, is based on the idea that if there is very high humidity, it will hinder sweat evaporation. Sweat evaporation is basically your body sweats to, you know, shed off the excess heat and provide cooling to the body. But if outside temperature is also high and the humidity levels are also high, the evaporation rate of the body, that is the sweating rate, would decrease, and your body will not be able to lose the heat, and it will feel more warmer. So sometimes you might have noticed that the actual temperature may be 35 degrees Celsius, but it may, your mobile app may display like it feels like 40 degrees Celsius. So how this extra 5 degree came? This came because of high humidity. So when the humidity is very high, your body may feel much hotter than the actual air temperature, because it cannot release the excess heat, and that is why the heat index is important, because it considers both temperature and humidity. So higher heat index, that is higher risk of heat stress and dehydration and heat stroke. So this is a equation. Usually we get charts also. We have discussed also how charts can be used. So this is equation just to highlight that the temperature and relative humidity parameters are considered to derive the heat index. This equation can vary for different regions as well. Coming to next topic, that is urban heat island. So urban heat island is a metropolitan area that is significantly warmer than the surrounding rural areas due to human activities and development. So in this figure you can see that in the central part, this is your urban area which is having large skyscrapers. On the rear ends there is a rural and sub urban areas. So this is the temperature in afternoon. So you can see that as you move from left to right and you come in this core zone, so this is where your temperatures are on the rise and your urban heat island is more predominant. So this UHI effect is more pronounced when you are in the mid of urban settlement. As you go away from the urban settlement, your UHI effect lowers down and there is more cooling effect. Now why UHI occurs? Because of the surfaces like concrete, asphalt, which trap more heat, and moreover these tall buildings, they block the wind, which which naturally cools. Also there is absence of vegetation, so the cooling effect is not there and the heat develops and it engulfs in a small kind of island or a localized effect which tends to provide more heating. Now due to this effect, there is increase in the temperatures, particularly in the night time. The cities become more hotter because your incoming heat is trapped inside this hypothetical bubble and the heat cannot exit outwards, and that is why the heating is more. Now there are three major types of UHI, particularly your surface UHI, and second is atmospheric UHI. Your canopy and boundary layer are subtypes of atmospheric UHI. Surface UHI refers to the heat of urban surfaces like roads, rooftops, which are usually measured by satellite or infrared sensors. Canopy layer UHI, that is the air temperature within the urban canyon, that is particularly due to the building which are created and they are measured by ground level sensors. Boundary layer UHI is at little higher level above the building where the heat gets mixed. So here you can see that this is the direction of wind flow. This is a rural boundary layer. So this surfaces of the paved and the building. So this, particularly the small surfaces, this is the surface layer UHI. Then based on the building, a small layer forms. So this forms the canopy UHI. So whatever the canopy is forming, that is a canopy UHI, and above that, this region, that is a boundary layer UHI, that is way above the buildings but over the aerial extent of the city where the heat gets mixed. And when you move ahead, then you have the rural boundary layer. So SUHI exists at all time, but your atmospheric heat island, that is more predominant at night and very insignificant during the daytime. What are the causes of UHI? That carbon emission is one of the foremost causes. Low albedo of the material. Albedo refers to the reflectance, that is a dark surfaces will absorb more heat and reflect less heat, and the light surfaces will reflect more heat. So because of more darker surfaces, there is more absorption and less reflectance. So that is again a reason of UHI. Then air pollutants, the air pollutants will entrap the heat in the local atmosphere, and that is why the heat will increase. Due to winds, there is less convection because winds are blocking it, so the natural cooling is hindered. Then you have urban canopy, which trap the heat in between. There is less greening, so there is less cooling efficiency, and the excessive use of air condition also release heat into the atmosphere, and these all increases the urban temperature. What are the effects of urban heat island? Primarily it affects your health, that is there can be heat stress, heat cramps and exhaustion. So there is a very high chance of harm to the human health. Nowadays we are seeing that in urban areas the tree shelters are very less. So in case of extreme heat, you cannot take a shelter in beneath a tree also, or if there is a tree, many people will be standing beneath the tree. So that is again a very harmful effect. Also now the governments they are employing sprinklers. So in case of a traffic intersection where the traffic is standing here, so they are providing temporary shades and sprinklers. So they are also provided to mitigate the heat effect. Air quality, because of heat the air quality also declines, then it causes more air pollution. There is rising demand because more heat will require more air conditioning demand, so there is more energy consumption. It also affects the urban system. The microclimate is getting altered, and there is a large scale environmental degradation, and which have far reaching ecological and economic impacts. Highlights of this week learning. So we learned that what the heat wave are usually abnormally high temperatures which are more than normal temperatures which occur during the summer season, particularly March to June. Sometimes it can extend till July. IMD specified some threshold criteria that if for the hilly region, if the temperature exceeds 30 degree, coastal region 37 and the plain region 40 degree, it can be a heat wave. Apart from that, the criteria that if the deviation is from normal temperature, that is also a criteria adopted by IMD. Heat stress is a condition where your body cannot shed excess heat, which leads to increase in the core temperature of the body and the heart rate as well. Because if the humidity levels are very high, your sweat evaporation would reduce and your body will feel more hotter than the actual air temperature, and that is why your heat stress would develop. Urban heat island is a phenomena where your metropolitan or the developed area would experience more heat compared to the surrounding area. There are two major types of urban heat island, that is the surface and the atmospheric, which quantifies the heating phenomena, and your atmospheric is further divided into canopy layer and the boundary layer, UHI. Lastly, UHI impacts human health and comfort, primarily these things, which is followed by air quality degradation, then deterioration of ecological and environmental factors, also affecting the microclimate, and increases the energy consumption. Here's a glimpse before the hands-on session. We'll analyze the temperature data to derive the lump series for a region. We'll estimate the excessive heat factor and its severity for a region. We'll prepare spatial maps of heat wave conditions based on EHF, and then we'll analyze the temporal variability of heat waves based on EHF severity. So thank you for your attention. In the next lecture, we'll meet on discuss the hands-on session on assessment of heat waves and heat stress.